This is the second lecture on designing a distillation column. In this lecture, we will talk about the packing material that we can use with the tray design to obtain a better separation efficiency. And in this lecture, we will also talk about some important parameters which affect the distillation column efficiency, and we will also be discussing the overall uh, operation of the distillation column in this lecture. As we talked earlier, that trays actually acts as a mini column, and these trays will be serving as a small separation unit. uh, Higher the number of the smaller higher the number of separation unit, better will be the separation efficiency of the column. So these trays uh, are involved in utilizing less energy, and they have less construction cost. So if we want to improve the overall separation efficiency of the column, we will add some packing material to the trays. So these packing materials are passive devices. They are designed in such a way that they will increase the interfacial area of the vapor liquid contact. It means these packing material will offer a higher interaction between the vapors and the liquid. Uh, More chances of interaction between the vapors and liquid will be offering a better separation efficiency. So in this slide you can see there these pictures of some packing material. These are supposed to impart a good vapor liquid interaction. So when a particular type is placed together, and these packing materials are involved, uh, low drop low pressure drops, uh, because if a high pressure drop would be involved, then more energy will be required to drive the vapors up to the distillation column. So it means these packing materials will be involving low pressure drop, so it's easier to direct the vapors to move the distillation through to move through the distillation column. Less energy will be required, so these packing materials will be considered as energy efficient. And in this way, when we add this packing material to the trays, the overall separation efficiency will be enhanced. When we see these trays in combination with the packing material, as this tray column which is facing some throughput problems, so there are some requirement to be made in this tray. So we will a small section of the trays will be replaced with the packing material, due to the packing provides extra interfacial area for vapor and the liquid interaction. So these packing material will be providing higher frequency of the interaction between the liquid and the vapors. So higher the frequency of the liquid vapor interaction, better would be the performance, better would be the separation efficiency. The efficiency of the separation is increased for the same column height. And the third one is packed columns are shorter than the trace column. So these are important parameters due to which these packing materials are augmented to the tray design. So packed columns are called continuous contact columns, while trade columns are known as stacked contact columns because of the manner in which vapor and liquor are contacted. Here are some factors which are responsible for the poor distillation column performance. These are feed conditions. Number two, this feed condition and reflux condition. This feed condition will also include reflux condition and the liquid and the vapor flow conditions and the state of the trace and the weather conditioning. So these are the parameters which affect the distillation column operation. We will discuss these parameters in detail in next slides. Among other factors which affect the distillation column efficiency, separation efficiency, feed condition is the first one. Feed conditions means the state of the feed, uh, the composition of the feed, and the location of the feed trays. This is very important while handling the distillation column. And if we are deviating from the design specification of the separation column, then the column will not be able to meet the required separation task. To overcome the problem associated with the feed, some columns are designed in such a way that they have some multiple feed points when the feed is expected to contain a variable amount of components. And along with this feed condition, separation reflux condition is also very important. Reflux, as a reflux ratio increases, the more and more volatile compounds are being recycled back to the column. So separation then becomes better, and thus less trace will be needed to achieve the same degree of separation. It means a higher reflux ratio means the lesser amount of the trays, the lesser number of trays will be required for better efficiency. On the other hand, if the reflux ratio is decreased, then the larger number of trays will be required to to meet the requirement of the separation efficiency. So most columns are designed to operate between 1.2 to 1.5 times the minimum reflux ratio, because this is approximately the region of minimum operating cost. More reflux means higher boiler duty. When vapors are allowed to pass through the liquid, then liquid will expand, which would be known as the process of foaming. This process of foaming provides opportunity to interact vapors with the liquid. Excessive foaming often leads to liquid buildup on the trays. However, in some cases, foaming may be so bad that the foam mixes with the liquid on the tray above. The process of foaming will occur, which depend primarily on physical properties of the liquid mixture, but it also depends upon the design and condition sometime. Whatever the cause of the foaming, this foaming process can reduce the separation or efficiency of the distillation column. So if we want to enhance the separation efficiency, then the foaming must be reduced to optimum level that can provide a minimum or optimum interaction between liquid and the vapors. Entrainment refers to the amount of liquid that is carried by vapors up to the tray, and this entrainment is caused by high flow rate of the vapors. The process of distillation is supposed to separate different components depending upon their boiling point. So the low volatile component will remain at the lower side, at the lower bottom, at the bottom of the container, while more volatile compounds or components will move upward in the top section of the column. But this process of entrainment, which is occurred by carrying a liquid by the vapors, is detrimental because tray efficiency of separation is reduced. And this is why, because lower volatile material is carried to the plate holding liquid of higher volatility and got mixed to create a mixture of different component with different volatility. Therefore, the process of entrainment could lead to the contamination of high purity distillate. So precautions must be taken to reduce this effect of entrainment, which can lead to the flooding. Weeping or dumping is a phenomena which is caused by low vapor flow. The pressure exerted by the vapor is insufficient to hold up the liquid on the tray, and resultantly the liquid starts to leak through the perforations, through the holes. Excessive weeping will result to dumping. This is that is a liquid on all the tray will dump, they will crash through the base of the column, and the column will have to be restarted. Weeping is a indicated weeping is a indication by a sharp pressure drop in the column, and these weeping and dumping phenomena can reduce the separation efficiency of the column. Weeping is due to the low vapor flow, while the flooding is brought about by excessive vapor flow, which is causing liquid to be entrained in the vapor up to the column. The increased pressure from excessive vapors also back up the liquid in the downcomer, causing an increase in liquid holdup on the plate. So depending on the degree of flooding, the maximum capacity of the column may be severely reduced. Flooding is detected by sharp increase in the column differential pressure, and this process significantly decreases the separation efficiency of the column. State of the trays and the packing is a third parameter which affect the separation efficiency of the distillation column. It is important to mention here that actual number of trays required for a particular separation duty is determined by the efficiency of the plates. So if the plates are efficient, then the number of trays will be lower, and if the tray plates are not efficient, then the number of trays will be higher. So the actual number of trays required for a particular separation is determined by the efficiency of the plate and the packing material that we are using uh, with the with these trays. So any factors that can cause a decrease in the tray efficiency, certainly it will change the performance of the column. So the tray efficiencies are affected by fouling, wear and tear, corrosion, and the rates at which these occur. So in order to get a better separation, appropriate material should be specified for the tray construction. Weather conditioning is the last parameter which affect the efficiency of the separation in distillation column. Uh, most distillation column are open to the weather conditions. However, many of the columns are insulated, but the changing weather conditions can still affect the column operations. Therefore, the reboiler must be suitably sized to ensure that enough vapors can be generating during the cold and the hot season. When we talk about the components of distillation column, these distillation columns contains several components, and each of them is used to transfer heat energy or material. A typical distillation column contains the following components which are listed here in this slide. Number one is a vertical shell, number two column internals, number three reboiler, number four condenser, number five reflux drum. So the first component is a vertical shell which is used to separate different liquid component in this area. So when a mixture of different components is introduced in a vertical shell, the separation will start. The separation of this mixture of component will occur on the basis of their boiling point. The components which have lower boiling point, they will have a high volatility and they will go to the gaseous phase, and the remaining components which have high boiling point, they will be carrying a low volatility phenomena with them. So these low volatile compound will be in the lower phase, which is with the bottom. The second part, which is the column internals such as trays, plates or packing, which are used to enhance the component separation. Different trays are uh, being used in these distillation column, such as bubble cap trays, valve trays and sieve trays. So among them, these bubble cap, valve and sieve trays were found to be more efficient for the separation of different compounds. Number three is a boiler, which is used to provide necessary vaporization for the distillation. This reboiler provides the sufficient amount of energy to the molecules, and these molecules or these components of the mixture uh, will be going to the next stage of vapors, and these vapors will segregate from the compound with a high volatility. The fourth component, which is a condenser, which is to cool down the vapors which are coming from the mixture. This vapor will carry a higher energy, and when they strike with the condenser, their energy will be lowered down and they will come back into the liquid state, and this is phenomena which is performed by the condenser. So last is a reflux drum, which is used to hold the condensed vapor from the top of the column so that the liquid reflux can be recycled back to the column. So these are the 5 components which are used in distillation columns. The vertical shell houses the column internals, and together with the condenser and reboiler constitute a distillation column. You can see here in the slide a schematic diagram of a distillation column, and you can see here a long section which is a distillation column, and each has 2 parts, rectification section and the stripping section. Stripping section is the section where low volatile compounds are going to stay there. However, the molecules with a higher uh, volatility, with a low boiling point, they will go in the top section, in the rectification section. Here is the top on the top of the schematic diagram. There is a condenser which is used to condense a high energy components which are in the state of vapors. They are condensed and they are transformed from gaseous state into the liquid state. Then these condensed form the liquids will be brought to the reflux drum, where this reflux drum is used to segregate into 2 parts. The distillate section is you can collect distillate into another container, while the remaining part is again uh, sent for the reflux, and it is introduced in the distillation column for further processing. And you can see here the heat in and heat out. This is basically you can use a hot plate, you can use any instrument that can provide a sufficient amount of heat to the mixture component. So these component will go into the vapor state according to their volatility and the boiling point. In this slide we will try to learn that how distillation column will work. In the first step, we will have to supply some suitable amount of energy to the boiler, and this reboiler will supply this energy to different component present in the sample mixture. The components having low boiling point will be vaporized with a small heat, with a small amount of energy. However, the molecules with a higher boiling point will take a lot of energy to get vaporized. After these source of heat can be any suitable fluid, and normally in most of the chemical plants steam is used uh, as a source of heat which is given to the reboiler. The liquid removed from the boiler is known as the bottom product or the bottom, as these bottom product contains almost all those compounds which have high boiling point, and they will have a low volatility. They will have a high boiling point and low volatility. Then the components with the low boiling point and higher volatility, they will move up to the column, and it exists in the top unit of the condenser column, where these vapors of high energy will be cooled by using condenser. After condensing this vapor, these gas molecules will be converted into the liquid molecules, and the vessel which is used to hold this liquid, which is condensed liquid, is known as a reflux drum, and some of the liquid is again recycled back to the top of the column and is known as reflux. The condensed liquid that is removed from the system is known as distillate or the top product. This is schematic diagram of distillation column. In this schematic diagram, the first step is elaborated. The first step is to introduce the component mixture, which is going to be separated in distillation column. You can see the arrow in the yellow color. This is the feed which is introduced in the middle of the column. The feed may be in any state, from a cold liquid to a superheated vapor. When this mixture of component is introduced into the distillation column, then the process of separation begins. As we talked earlier, that there are column internals, which are trays. Different type of trays are used, which the function of these trays is to separate different components which are present in the column feed. So depending upon their boiling point and volatility, these components will be separated in the distillation column. This diagram shows that liquid and vapors are in countercurrent contact throughout the column. As the liquid flows down and the vapor flows up the column. At each distillation stage, some of the vapors moving up the column is condensed and in return evaporates some of the liquid moving down the column. If there are two components in the feed, then a greater amount of less volatile component will condense at each stage and greater amount of the more volatile components will evaporate. So the mixture which contain different components, when they are introduced in the distillation column, there are two basically stages. One stage is the liquid state and other is the vapors which got a small amount of energy from the reboiler. When these liquid and vapors are uh, interaction. So after interaction, some of the molecules which have lower volatility, they will fall back, they will condensed and down, moving down the column with the liquid. However, so the components which have high volatility, they will move into the upper section of the column. So in this separation stage, in distillation stage, different components of different volatility have been separated by using this distillation column. The rectifying section, which is mentioned here by a yellow colored arrow, this is a section uh, where the concentration of more volatile components increases in both the liquids and the vapors. So above the feed point, the top section of the column contains almost all the components which have low boiling point and they are more volatile compounds. So the compounds with a lower volatility, they will go to the bottom of the column. However, the more volatile compound will go up in the top section of the distillation column, which is known as a rectifying section. So the rectifying section is a portion where the concentration of more volatile component increases in both liquid and the vapor. Uh, However, the stripping section is the portion below the feed point where the concentration of more volatile components decreases in both liquid and the vapor. So these are the two basically parts. One is the stripping section, and one is another is a rectifying section. So these two sections basically composed of different components with different volatility. The rectifying section contains more volatile components while the stripping section contains less volatile components. The function of the condenser is to condense the vapors into the liquid. In condenser, a cooling water is being circulated. When the vapors of high energy they are collided, uh, they are interacted with the condenser. So the molecules which are in gaseous state they have higher energy, and when they collided with the cooling water surface they are low temperature. So these gaseous molecules will be transformed into a liquid state. So in the distillation column, the different components with the higher volatility and the lower boiling point, they will go up into the top section in the rectifying section. After the rectifying section, these vapors are introduced in the condenser, where the transformation of the liquid gaseous phase into the liquid state. ओके इस स्लाइड के अंदर हम लोग देख सकते हैं कि जो कंडेंस हुआ था, जो कंडेंसेट था, जो हमारे पास रिफ्लेक्स ड्रम में आया था, उसमें से दो पोर्शन हम कर लेते हैं। उसमें से कुछ पोर्शन जो है हम वापस रिफ्लेक्स जो है वो कॉलम में भेज दिया जाता है फ्रॉम टॉप कॉलम, और कुछ जो हिस्सा है उस कंडेंसेट का वो हम अलग कर लेते हैं। राइट सेक्शन पे अगर आप येलो कलर का साइन देखेंगे तो ये जो कंडेंस होने के बाद जो हमारे पास कंडेंसेट आया था उसको हमने अलग एक प्रोडक्ट ले लिया। तो ये यहाँ पे हमने इसको बाइफरकेट कर लेना है, जो हमारे पास दो हिस्सों में तकसीम कर लेना है। कुछ हिस्सा हम अलग कर लेते हैं, उसे हम कॉलम की प्रोडक्ट भी कहते हैं और ओवरहेड प्रोडक्ट भी कहते हैं, और कुछ हिस्सा जो है हम रिफ्लेक्स जो है वापस कॉलम के टॉप से वो एंटर करा देते हैं, वापस वो नीचे कॉलम में आता है, वहाँ पे रिबॉयलर तक जाता है। रिबॉयलर जो है तो रिबॉयल करता है अगेन, जो कंपाउंड की कंपाउंड जो है वो बॉयल होते हैं और अपनी वोलेटिलिटी और बॉइलिंग पॉइंट के हिसाब से वो वहाँ पे उनकी वेपोराइजेशन होती है और वो कॉलम से अगेन एग्जिट करते हैं। After condensing the vapors into the liquid, this condensed liquid is further distributed into two products. The one product which is obtained from this distillation column is known as overhead product, and other section which is again sent back to the distillation column for further purity and separation. The bottom liquid, containing the least volatile components in the feed, flows from the base of the column to the reboiler. In this heat exchanger system is used to vaporize some of the liquid which flows back to the column in the countercurrent flow. With the liquid moving down the column, the amount of heat fed to the reboiler determines the vapor flow to the column. So this reboiler will supply amount of energy to the bottom liquid, which is further energized and sent back to the distillation column for separation. After getting the overhead product, the second product, which is known as bottom product, has a specified composition and fixed during the design of the column, and is the second product stream from the distillation column. So these actually components which with a lower volatility, these will be obtained in the bottom product of the distillation column. One of the main steps in the column design is specifying the column operating objectives, and these objectives are defined by the primary product composition and an optimal recovery of the product from the waste, recycle, or less important byproduct stream. So these specifications should be in terms of heavy key impurity in the top stream and the light key impurity in the bottom stream. After specifying the top and bottom stream composition, the dew point of the top stream and the boiling point of the bottom stream may be determined using different amount of pressures. An operating pressure should be selected that allows acceptable temperature differences between available utilities, because an overhead vapor must be condensed and a bottom liquid must be reboiled.